So whenever we move fast with a cup of coffee in our hands, there's a high risk of spilling it. Why is that? In technical terms, we say the coffee gets into resonance with our walking movements. If you're not familiar with the term resonance, then think about sitting in a swing. If you always move your legs at the right time, you transfer more and more energy into the swing and you get higher and higher. For coffee, we want to avoid such a resonance, and we have three major solutions for that. Solution number one is we slow down our speed and reduce the energy transfer. Solution number two is we put a lid on our cup, which is kind of the favorite solution for coffee to go. And solution number three is we're coffee ninjas and balance our cup. What does this have to do with an orbital rocket like New Zealand's Electron here in the background? The Electron rocket has massive tanks with a lot of fuel in it. And the fuel can get into resonance with the rocket movements on its way into orbit. Fuel slushing is actually such a serious problem that even big companies or agencies like NASA and SpaceX have lost some very expensive rockets due to slosh resonance. If we now transfer our three coffee solutions to our rocket, then we see that solution number one, slowing down the speed, is obviously not a great idea. Instead, all companies use solution number two, the lid solution. And they do that by changing the structure of the tanks, which means they add ring structures, so-called baffles, into the tanks, which dampen the slosh, down to a more harmless behavior to avoid resonance. The only problem with that solution is that these ring structures are not only very heavy, but also very expensive in contrast to our free coffee lids. That's why my research goes for solution number three, the ninja solution. I'm going to upgrade the flight controller or brain of our rocket by first identifying our slosh and rocket motion behaviors, and then by upgrading the flight control strategy to avoid resonance. All in all, it's about doing the right movements at the right time. In summary, my PhD used mathematical algorithms instead of additional mechanical heavy parts to handle the fuel sloshing, which will make our Electron rocket here much cheaper and more energy efficient. Thank you.